Combining different types of variation. In the sciences, relationships between 3 or more variables are common, and any combination of the different types of proportionality we've discussed is possible. For example, if the quantities x, y, and z are related by the equation z equals k times x times y, then we say that z is proportional to the product of x and y. We can also express this relationship by saying that z varies jointly as x and y, or z is jointly proportional to x and y. If the quantities x and y are related by the equation z equals k times x over y, we see that z is proportional to x and inversely proportional to y, or that z varies directly as x and inversely as y. Let's break those apart, because that can be confusing when you're looking at all these vocabulary words. All right, so if we have direct variation, it's proportional. It's multiplication. And it's in the numerator. If we have indirect variation, it's inversely proportional. It's division. And it's in the denominator. All right, so just need to figure out, is it proportional? Goes in the numerator. Is it inversely proportional? Goes in the denominator. Let's look at an example. Combining variations. The apparent brightness B of a light source measured in, I think W is watts, watts per meter squared. It doesn't matter, just a unit of measure. Is directly proportional to the luminosity L, and L is measured in, I guess, watts, of the light source, and inversely proportional to the square of the distance from the light source, measured in meters. So what we need to worry about is B, L, and D. All right, so if it is directly proportional, it's in the numerator. It's multiplication. All right, so that means that L, if it's directly proportional to L, L is in the numerator, and it's multiplied by K. All right, because K here is our constant of proportionality. There has to be a constant of proportionality for directly proportional. And inversely proportional it's in the denominator, it's division, and that's D. Now we don't need another K, we already got one K. All right, so this will become a fraction with L in the numerator and D in the denominator. So now let's write the equation that expresses the relationship, oh, excuse me, not D, D squared, don't forget square. All right, so now let's write the equation for A here. So that means B here is K times directly proportional, so that means L is in the numerator and D squared is in the denominator. And that's it to writing the equation. So just putting things in the right place. If the distance is doubled, by what factor will the brightness change? All right, so we're going to, if we're doubling the distance, all right, so we're going to replace D with 2D, right, because our distance is doubling, right? So now let's write our equation. So B equals K times L divided by 2D all squared, right? So you're replacing D with 2D because that's twice the distance, right? So now we've got B equals K times L divided by, now that would be 4D squared, right? Because we have to square the 2 as well, all right? So if the so notice we've got now 4 in the denominator. So 4 in the denominator is 1/4. So the brightness will be 1/4 as much if the distance doubles. Where are we going to put C? How about, I don't feel like making this longer. Let's just put C right here. Let's see if we can squeeze it in. All right, so if the distance is cut in half and the luminosity is tripled, by what factor will the brightness change? All right, so the luminosity is tripled, so that means we're going to replace L with 3L and replace D with 1/2 D. So brightness equals, so we have K times, and then the L goes in the numerator, so now that's 3L divided by 1/2, D, and squared. The whole thing will be squared. All right, so now let's simplify that. So B equals K times 3L. All right, so 1/2 squared is 1/4. Dividing by 1/4 is the same as multiplying by 4. So that means B equals K times 3 times 4L divided by D squared. I need just like a teensiest bit left of space more. So 3 times 4, of course, is going to be 12. So B equals K times 12L divided by D squared. If we move this, we'll have enough space. There we go. Plenty of space. Now, what does that mean? It means that the brightness will be 12 times as much. And I guess we'll put it over here. Brightness will be 12 times greater if we triple the luminosity and decrease the distance by D. And that makes sense. If you're closer to a light source, it's going to be brighter. If I increase the luminosity, increase the wattage, it's going to be brighter, right? So there we go. All right, so the relationship between apparent brightness, actual brightness or luminosity, and distance is used in estimating distance to stars. So there's a practical use for that. All right? And so when you're setting these up, just pay attention. is it directly proportional? It's in the numerator. If it's inversely proportional, it's in the denominator. And don't forget your constant of proportionality. Here we didn't solve for it. We weren't given any values, so it's just going to be k. But we could still figure out how the overall brightness will change based on changing the distance or changing the luminosity. Proportionality, shape, and size. Many real-world quantities are related to proportionalities. We use the proportionality symbol, that little squiggle there, to express proportionalities in the natural world. For example, animals of the same shape, the skin area and volume are proportional in different ways to the length of the animal. So how much skin you have and your volume is proportional. That makes sense, right? We can use proportionality to determine how a frog's size relates to its sensitivity to pollutants in the environment. And aren't those little froggies cute? Example 4, Newton's law of gravity. So last example here, and it's just setting it up. Newton's law of gravity says two objects with masses m1 and m2 attract each other with the force F that is jointly proportional to their masses and inversely proportional to the square of the distance r between the objects. Express Newton's law of gravity as an equation. All right, so we have F, or force. So let's look. We have proportional. So jointly proportional, that's the same as directly proportional. Jointly just means it's going to be a product. So jointly proportional to m1 and m2. This part will be in the numerator. And inversely proportional to the square of the distance r between the objects. Okay, so square means you're squaring. Square root. It's not the same as square root. So that goes in the denominator. So we can write Newton's law of gravity now as an equation. Now that we have the pieces we need and we know the relationship. And again, we're not solving for k here, but remember k is the constant of proportionality. We need values to solve for what k is. They give us the masses and the distance, then we can solve for k. Right now, k is just going to be k. It's not a variable, we just don't know what it is. So F is equal to, all right, jointly proportional to their masses. So m1 and m2 go in the numerator. The distance r squared goes in the denominator. And don't forget your k. And that's it. There we go. We have written the equation for Newton's law of gravity. Just a matter of interpreting what those two terms, directly proportional and inversely proportional, mean. All right, and that's the end of this video. Thanks for watching. Bye for now.